Okay. We are going to present on federated learning for mobile keyboard prediction. I, Mangaldi Banerjee, along with my teammate Amar Kumar, Sagar Chakrabarti, and Nikhil Sharma, will talk on this topic. So, what we are going to learn through the presentation. First is the privacy concern we have with our smartphone apps like Gboard or any other apps. How to resolve this security issue. Okay, and how the app learns from my data to improve its performance. We are also going to learn about Gboard, Google's own keyboard. Also going to learn the how these smartphone apps train their model using our data, and we will compare our traditional training process and this federated process. Okay, pretty much we all use the smartphone keyboard apps like Swift Key or Gboard for typing purpose. Okay, and the prediction we get is pretty accurate. Okay, so this is one amazing thing. But here is a question: how this app get to know what I'm going to type next? Okay, how this app train himself that I'm going to write this, after that I have to predict that. Okay, this use artificial intelligence, and in that it uses some data to train his model, and it gets the insights of the data and it predict the next word. Okay, but are you ready to share your personal data to some app provider like Google or Microsoft to train their models? I think no. The problem statement is we want better prediction, but we don't want to share our personal data to them. Okay, so here come the solution. This is federated learning, privacy sensitive solution provided by Google. This keeps the data on the devices, and the model of the app try to learn on the devices, and at the end, on the server end, they aggregate all the learning and share the final model. Okay, and nowadays we know that the phones have high capacity processing power. Okay, so it can train the model in the device itself. Okay, the data stays in the device. The model train the app train his model using the cache available in the phone, and it sends the final model. The model consists of only some numerical values, not any kind of data, to the server, and the server will aggregate all the models and make the final one. Okay, now the paper was written by Google team for their Gboard application. This is Google's mobile keyboard. It have 1 billion plus download in Play Store. It supports 960 plus languages, and 80% of its uses are for the chatting purpose. So how this thing happens? Okay, first uh, first the server of Google tries to connect with the Android devices or the devices which are using the Gboard application. Okay, it will check certain criteria like charging, it is on Wi-Fi or not, or it is the user is using the device or not. If it is on charging, then if the three conditions satisfied, then Google will select the device for the first round. Okay, we use this three condition because if this training will consume some amount of battery. Okay, so if the device is in charging, so the effect will be less, and also the training process needs high speed internet, so this should be on Wi-Fi, and it should not hamper the user experience, so they need it to be ideal mode. Okay, so the after the qualified devices of the first round, Google select a subset of the device stochastically. Okay, and they will send one basic model to the device to train on its data. Okay, so when this thing happens, basically when we sleep, when the mobile is in ideal mode or in charging or in Wi-Fi, the server, Google server, sends the request to the device to train his model. Okay, so how to train the app? How this done? This basically Google sends one model to the device, and the device train the model using the data available in the device, and after the training is done, it will send the updated model means neural network. Here it will send some neural network with some weights, so like 0 1 or some numerical values, to the server. Okay, and the server will get this input from all the devices he requested to train, and it will aggregate all the numbers it got, and it will make its final model. So let's come to result. Okay, so we have tested this model on two kind of data. One is server hosted data. Some users shared their data on the with the Google, and Google tested this on that data. The federated model performs pretty well compared to the server model, and also this testing was done on data caches available on client device. Their federated CIFG outperform than the traditional server model. Okay, and this data, this client owned data caches is more versatile, more diversified data is available in this, because they type in many kind of app, not only chatting, but they also type in Chrome or other kind of stuff. So that data is more diversified. Okay, so is it better? So yes, absolutely, this is better, because this is giving us a privacy sensitive solution along with high accuracy compared to the traditional models. Okay, and this is one deep rooted thing we can use not only to train Gboard, but we also can use this kind of technique to train other applications like Google Maps or some AI related application we use in our devices. So conclusion of this is giving us good privacy and also good accuracy, so we can use that. So here we learn that privacy concerned with the Android or smartphone apps, and we also learn on algorithm how to resolve that. Also, how the model training on the devices, and how the Gboard and training device selection, how the training time does, and how validation. We have seen that this is better than other models. So we have taken these references for making this.